with electric power, leaps in technology paved the way to a new way of life and a global economy. Then, the computer changed everything. Information technology and electronics led the third industrial revolution. Workplaces became smarter, technology got personal, and communication went mobile. The fourth industrial revolution is bringing together physical and digital worlds across industries to create an interconnected global value chain. Powerful technology, incredible connectivity, and unlimited information is available at your fingertips. Breakthroughs like machine learning, artificial intelligence, augmented reality, blockchain, robotics, and Internet of Things are rapidly changing the way we live our lives. The consumer is at the center of a connected ecosystem that delivers personalized needs at any time of choice. Business leaders across the world are gearing up to be a part of this ecosystem and be omnipresent for their consumers. New players enter and disrupt the game every day while constantly changing the rules. Organizations must change the way they work and strategize while adapting to the new world. It's time to leverage emerging technologies and seek collaborative opportunities to provide new and personalized experiences for everyone. Digitalization brings the world closer by erasing physical boundaries and breaking limits. It's important to keep up with the demands of a transforming world that seeks access to incredible opportunities in the most intimate of environments. Are you ready to lead the fourth industrial revolution?
Thank you. So guys, you must have got the idea that how the technology is changing the world and bringing the revolution is called the Industry 4.0. There are some folks basically who are saying that Industry 4.0 will bring, will take several jobs, because once you automate the things, then lot of jobs will go from the market. But that is not the right things. If you recall, basically many of us, when the computers were introduced in India, we were having the same kind of discussions. But indeed, the computers and the related areas have created millions of jobs. So in this talk, I'm going to discuss two main things. One is how the data and the data analytics is important for the survival of any company. They have to analyze the data. And when I say data, it can be the structured or unstructured data. When I say unstructured, it could be a video, it could be audio, it could be a text, it could be a semi-unstructured XML kind of data exchange protocols, or it could be a structured data like any transactional information, right? So second, I will take the number of use cases where data analytics at different stages have been applied and how those industries have been evolved right to the next stage. So for doing the data analytics, the underneath is the data, because we have to have rich source of information about the different enterprise business objects and the entities. And this information could be, as I said, could be structured or could be unstructured. This information can be scattered in number of enterprises, internal as well as the external data sources, right? And once we have the curated, that is cleansed information, then only we can make some sense out of it. If the data is dirty, then don't expect any, insightful, deeper insights from that data. So let's look at basically that how this data processing journey has been, and also the data analytics thing. So since the relational databases got invented in late 60s and early 70s, people were basically using these data as a transactional system like a IBM DB2 or Oracle or SQL Server and others. And they were basically managing the enterprise data on day-to-day data, whether it's about the products or whether about the transactions. And they were doing the simple data analytics. Can someone go on the mute, because there is still a lot of echo on the line? Can you? Okay, probably some disturbance at my end only. And then people were taking this data, they were dumping this data into the data warehouse. And data warehouse is a single repository where we pull the data from different data sources, aggregate that information and make some decision out of it. So a lot of data mining algorithms, the simple if what if kind of rules, they were applying the some data analytics being done on the aggregated information. And typically this aggregated information was a structured data. So for example, a big company which has offices, sales offices in number of locations in number of countries, they were basically getting the information from each of the country or each store and aggregating the information by day wise or weekly wise or monthly wise, and then they were deciding what are the campaign we should run, what kind of discounts should be given, how one store or one country business doing with respect to the other country, how the business from one store is doing with respect to the last quarter, and so on. So they were doing the data analytics on the structured data. Then enterprise needs grew. They realized, hey, we have lot of unstructured information in the organization. Like people are saying good and bad things in the reviews about the products. People are sending the emails. The client executive getting calls, right? And people are complaining or they are appreciating or they are supporting the things. So they were getting a lot of unstructured information in the form of text documents. So then enterprises have realized that, hey, how we can leverage the text data with my pure structured data and integrate this information and derive the insights. But the information about the business entities, say product or customer, is stored in the structured data, as well as basically customer are sending the emails, customer are calling, right? They are putting the complaints, people are giving the reviews. All that information is related, right? They would like to know which are the products basically they are getting most of the complaints. Now, there is no way basically you can do this kind of analysis unless basically you merge the complaint text or complaints emails with the structured data, and then you say, hey, most of the complaints are coming from the Mumbai area, or they are coming basically from the age of clients which are less than 30 years old, right? So they want to analyze both data and text, and that is what the enterprise information integration evolved in the late 90s, right, and the early 20s. And all the database vendors, big companies like IBM and other companies, they built basically the information integration, and they were taking the two approaches, either on the materialized approach or the virtual approach, right? Let the data be on the wherever the data is there, don't pull the data, right? But when the query needs the information from multiple places, let the query be analyzed at processor level and decompose the query into subqueries, and each subquery goes to the respective data source and executes locally, and then the results go back to the integrator site, and they are integrated, and then results are given, the answers are given back to the user. Then in the late 2000 or early 2010, people realized that, hey, other than the text and the data, we have lots of other information which is coming through different sensors, my video streams, and so on. Now they want to analyze the, say, video streams. They want to pick up basically that where the customers are going, which aisle are most popular where the customers are entering, right? They want to basically see the different temperature in the big store. If the people are not going to that, that area, then they want to basically turn the AC on of that area, right? So they want to basically bring the sensors, the video data, and they're dumping all that information into a lake where you pull the information. It's just like basically a garbage things. The garbage is coming from multiple places, and the person is dumping that data into one single place, and then there are some people, basically poor folks, they are taking the plastics out, and other things out and making that. The same kind of idea that applies in the data lake, that you dump the data into the data lake, and then you are setting some really intelligent agents which basically identifying the linking of the data, that okay, this data is linked to that data, this data is linked to that data. So they're discovering the various kind of entities and the linkages between them and analyzing that information. And that is what the enterprise data lake. So that in a very cohesive way, they are using all kinds of data, whether it's transactional or operational, right, or text or any other kind of data, and they're analyzing that all that information. Now the trend now is in 2010, and now is run, that how to make these systems trusted information or autonomous. Let the system should tell us what is emerging in the data, rather than some data analysts go into the database or into the data lake or into the enterprise operational system and does the analysis, right? That is basically, you are pulling the information. That era is almost getting over. Now systems are becoming smart and trusted, that they have inbuilt machine learning, the AI, those kind of algorithms, and we will see some of them, right? Where these algorithms or these agents are keeping an eye on the data and pushing the things which are interest to the business, right? That's the difference here, right? So the autonomous and trusted or intellective or intelligent data systems, through inbuilt data analytics using the machine learning and AI algorithm, they are throwing the insights. Rather than you pull the information, they are telling us basically, hey, this is the interesting pattern emerging in the database, right? One should look at that. And then business decision makers basically look at that one, and then they then basically design the things around that, right? So this is what the trend is moving to. Rather than doing the analysis from the top in the right and say, show me basically, okay, here is the algorithm, right? Execute this data analytics algorithm, compare my sales of this semester of this quarter to the last quarter, right? That is the old one. The new one, once the data goes inside, the system basically will tell you basically that in this quarter, this particular product of the type is the most popular, has been basically at the age of folks who are 25 and 35 on that particular area, right? So that is what is called the autonomous information systems and the trusted data analytics. And this is just a starting point. And here, what are the technologies that we are using? That what you saw in the Industry 4.0 revolution, which is AI, ML, and the blockchain. So I'm going to basically discuss a couple of use cases if time permits. Otherwise, the slides, the PDF version of the slides will be available to you, and you can look at the examples of the blockchain and that, right? And this is what we are calling it as a big data, along with the ML and AI, inherent ML and AI application in the big data, which basically does the massaging of the data and throw out the interesting pattern. Okay, next slide, please. Okay, so now you see the big data. Earlier, having a gigabytes of data was a really, really big data. Now even terabytes of data is not a big data, right? Petabytes of data is generated basically almost every day. Look at basically like our in own case in Veracity, right? Bharati, and this is a little bit old data. Bharati is creating 5 terabytes call data per day. When I say call data means who's calling whom data, right? When I make a call to Professor S.K. Singh, right, that it is the one or more call records are created, because when I make a call from here, it goes to the nearest tower. They say basically S.K. Singh is on that tower, that goes to the another, handing over to the another tower, and so on basically, and finally get connected to Professor S.K. Singh. So number of call records are generated when you make a call. Like that, basically 5 terabytes of data is generated every day. Now, data analytics, as I said, does not make sense if you analyze the data only for a day. No, it doesn't make sense. You aggregate that information, you look at the information for some time, and then you analyze that data. So if 5 terabytes of the data per day, and if you accumulate the data for, let's say, 6 months or 3 months, it becomes hundreds of terabytes. And analyzing that hundreds of terabytes, you want to see the popular network, you want to see basically the people who are making most of the call to one single person, right? You want to analyze all sort of patterns in that. It is not that easy, right? And that is what is the big data is, right? And many of you may be knowing, but I'll give you a very high level definition of the big data. What is a big data, right? And analyzing that information. Next slide, please. Next slide. Okay. So big data, as many of you may be knowing, it has typically the 4 V characteristics. Some say 3, some say 5 also, right? So volume, as big data means the volume has to be really, really large, right? That it is in peta or exabyte of data. And data is streaming very fast. The velocity, the data is in motion. Data is not at rest. Data can be at rest, but data is motion. Like, for example, when somebody is like let's say in the financial market, the stock stickers, right? The stock price is basically changing every milliseconds, right? People are buying, selling, and it's depending on the demand, basically they are but just price going up and down, right? And data is in motion. And when you put a filter, let's say you bought a, let's say, Infosys stock at a price X, and now you said basically if my stock price goes 5% and up from the purchase price within the 6 days of my buying, then sell it automatically. Now that means you are putting some kind of check or trigger there, right? And checking whenever the Infosys price is going, you check the price of that moment and your buying price, and if it is more than 5% within 6 days of buying of that Infosys stock, then the system will automatically sell that, put the order on the sell one, right? So the data is in motion, is running very fast. Veracity, the data is not only one type of data. Data is of multimodal information. You have a structured, you have an unstructured, your video, your sensor data, right, and so on, right? So you put all that information. And the last is veracity. It's a very, very important one. The veracity means when the data is in doubt, right? That it's not trusted. So the enterprise will accept the information if it is trusted information. It will go to the operational system if it is a trusted information. If the information is very noisy, we do not know basically who is the source generated that information, right? Data is always in doubt. So like, for example, the social media data these days, right? It is in doubt, big question mark. We don't know whether it's a fake video or fake news or not, right? So any enterprise will accept the data only when basically when data is clean, it's verified, it's trusted information, right? But when in a big data, in a multi-channel information, when you are getting that, right, some of the data may be noisy. Like for example, if you have a sensor, right, the sensor might basically give the wrong temperature, right? So how to clean this information is a very big question. And when you develop any application and you are getting the data from multiple sources, trust me, most of the time that goes in preparing the data. You prepare the data in such a way so that it can be consumed by the application. If the data is not prepared, right, it cannot be consumed by the application. So most of the time of the developers, it goes basically in the data preparation time. Next slide, please. So let me, yeah, this is animated slide. There are many of them. Press one. So now, since we cannot visualize the data in the 4 or 5 dimensions, let's take a 3 dimensions, right? Volume, velocity, and variety, and these are the most 3 dimensions, right? And there has been tons of work in this in these areas, right? So there is an NLP community. They have done lot of work in handling or processing the text data, right, along with structured data, right? But they have taken basically, let's say, the Google, right, search. They have tons of millions of hundreds of millions of documents, and then they basically do the key phrase extractions and they index that information. So, right, and they extract the entities out of that, right? So NLP community or text processing community, they have applied the machine learning, deep learning, and all the neural network, all those sort of things basically for processing more unstructured information with less structured data. Next. Similarly, there is a event processing community, which is the distributed computation or distributed systems, right? They have done a lot of how to handle the data which is in motion, right? So all the streaming computing, data streaming, the distributed systems people basically know how to handle such kind of variety of information, which is of structured and unstructured, but more importantly, it is committed very fast rate. Next one. And whereas the database community, they have developed algorithms and methods for handling large amount of unstructured data and little of unstructured information. Those who work in the database area, right, when you basically create the tables in any databases, let's say in IBM DB2 or any ones, right, you create basically the tables which have more, structured field. The text field, right, there are very little, and you can handle only the little text using, those predicates there for search. So the database community, they know how to handle the large amount of data, and the intersection of all that is basically or the union of all is called as the big data. That is, they are applying all these algorithms or developing the new algorithm for handling large volume of data, which is in varieties of nature, which is coming at a very fast pace. Next slide, please. So now let's look at that. Why do we need a platform or new, platform to process the big data? So developing any new system or any new platform, the need arises when we have the new applications. If the new applications can be satisfied with the existing algorithms or existing systems, then we don't need any new platform. The need of the new platform arises when we have the new applications which cannot be satisfied with the existing systems. So what are the new applications? That we want to do the cognitive analytics. We want to develop the systems which can talk to the end client without basically having a back-end person. We want to make the systems smarter. As I said, we want to push the information to the user, what the interesting emerging patterns are emerging in my big data or autonomous data systems and the trusted database systems. So the cognitive analytics. And what is a cognitive? Cognitive something is something which the machine can understand the data, can do the reasoning on that data, and can look at new pattern. We look at basically, how to react that, right? Once we have this new applications, that means basically the new applications requires the new capabilities, right? And to support these new capabilities, we need to develop the new technologies. And new technology does not mean basically we completely throw out the old one and start inventing the new one. How to build the things on top of the existing technology so that basically we can build the new capabilities, right, to satisfy the new applications, right? And for developing the big data platforms, there are many open source technologies, right, in terms of the algorithms, in terms of the data curation methods, and data integration methods, even the data analytics methods also, right? Next one. So now let's see the journey, right? So if you look at the motivation that I told you, that we had or still we have the systems which are system of records. That is, it's a transactional. So for example, the banks have the information about they have our profile information, right? And they maintain our profile, who we are, what is our address, what kind of business we provide to the bank, right? And they have basically the transactional information. So they have the information who we are, what products we are owning, and how we are using those products. Where those products could be a credit card, it could be a saving bank account, it could be a checking bank account, it could be a home loan, or it could be anything. So this is what the system of records, right? So system of records, they have been doing a very kind of descriptive analytics, and their addresses, very simple examples about who is the one, who are the customers, whose bank balance is more than 5 lakhs, who are the one who are spending more than 1 lakh rupees per month on the credit cards, right? They are doing basically who kind of analysis, right? So this is called the descriptive analytics, and this descriptive analytics is done underneath my data sources, and that data sources could be any operational. Typically it is done on the operational and the application databases. Then there is a need for the predictive. Okay, they look at my pattern, how am I spending the money, and then they predict basically that where I can spend the money, right? They predict what will be my salary in 2 or 3 years from now, what will be my need, right, for 2 or 3 years from now. They predict that, and based on the prediction, they build some campaign or they build some product based on that, right? So this is what they analyze this information. So this is what called the system of insights. The system of insights means that we have the enterprise has collected lots of information where they analyze that information, do the predictive analytics, and from that predictive analytics, basically they derive the insights about you, about your needs, about your association with other things, about that they identify that this is a group of people who are the same, and they look at the next group of people, how far they are. Means when they will have the needs of this people of this group, right? So that is what the predictive analytics. Then next is the prescriptive analytics. Prescriptive analytics is a kind of what if kind of things. So very simple example of prescriptive analytics is like a doctor does. Doctor gives us a prescription. Doctor analyzes the symptoms of today, right? A patient basically tells that these are the things I'm feeling, blah, 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 right? And then doctors basically based on the knowledge that, oh, okay, this guy is having a sore throat, this guy, it will convert into a fever, right? So prevent that fever or prevent the future symptoms, the doctor prescribes the medicines. And this is what the prescriptive analytics is. So something, if you know that my, temp file in the system is getting full, it is now 88% or 76%, the system takes the corrective steps to swap the data or to delete the data or to recommend this, delete these things basically, so that it can make more space, right, to have the temporary files. So this is called the prescriptive analytics, and that comes to through insights only. But the trend which is going on, and initially trends basically that also you see in now these enterprises, is the system of engagement. And system of engagement, that how you can engage without any intervention, without any human being on the back end, how you can interact with the system, right? Like Alexa, Evie, right, Maya, and so on, right, which are there basically on the website, and you let basically give your queries, and then the system basically gives you the answers, or system basically analyze the information, your situation, whatever the interaction that you are going, right, and then giving you that information. So one of the projects that we are doing on the cognitive analytics is for the social cause, right? So these days, many people are suffering, some mental health problem, right? Because of whatever, right? So we have been developing where a person comes, start dialogue with the system, telling all the things that, look, last night I could not sleep, and this and that, and this and that. We figure it out. This guy is suffering from depression or anxiety or greediness or this or that, basically. And based on that symptoms, we give the remedies, right? That is what we are doing. We are applying the AI in doing this kind of cognitive analytics. Next, one time. So now, in order to do this descriptive, predictive, prescriptive, or cognitive analytics, the number of technology that we have been using, right? So like descriptive analytics and any database systems like IBM DB2, right? You use the SQL or application form-based things basically to execute and analyze the information. Or you do basically simple Excel sheet, right? In the Excel sheet is like a descriptive kind of analytics, right? They are also basically you are doing, these kind of analysis. Or you can have a business flow. That is, you can have a workflow sitting on top of your database where a query comes in, analyze the situation in a what if kind of, if then kind of things, and goes basically in a workflow environment, right? Like you file a insurance claim, right? And then there is a guy basically who looks at basically, are you eligible for the claim or not. It looks at basically, for example, the rule is that you can claim only twice in a year. It looks at basically, are you qualified or not? If yes, then what is the eligibility of your, this. So there is a workflow that in every step it's checked, and that is sitting on top of doing some kind of descriptive analytics on that. On the predictive analytics, right, we use all the data mining, some kind of forecasting simulations, right, and some kind of limited data and text analytics, conjoint analytics of data and text. And in the prescriptive analytics, we heavily apply the AI and ML, right, to look at the features which are emerging, match those patterns with the already existing patterns which we have proven, which we have seen proven once. And then we see basically that, hey, if it is a fever kind of things, sorry, it is a sore throat, it is converted into the fever basically converted to this, then preventing that. And that is what basically they apply, AI and ML kind of technology. But there is an uncertainty. So how to handle the uncertainties and optimize that. And the last and the most, where we are transforming the industry 4.0, and everybody, even the researchers, are focusing on the cognitive one, is the complete automation with scale, right? The scalability is the core problem which we in academia, right, don't even bother about the scalability, right? We just do a complete proof of concept, right, and is doing this and move on. But to make any system to work in the real life, we have to look at basically, is it scalable? Can it work in a different situation? Can it handle hundreds of thousands of users concurrently, and so on, right? And then basically use the adaptive and continual analytics there, right? And as I said, basically it's a multi-party collaboration in the cognitive analytics, and you heavily apply all these deep learning, NLP, those kind of methods over here, right? So that is what the journey is. We descriptive analytics using the Excel sheet or simple databases to the complete automation, right? Directly interacting with the system. Let the system basically figure it out, my needs based on the inputs that I provide, and the system is basically giving me the things. And I'll give you one example, and I don't think basically I can reach to that one because I have a hard stop in 30 minutes from now. So we developed a system almost a decade back, and this was published in, I think, either in Sigmod or VLDB, which is the top conference, right? Is a call assist, which is on the cognitive analytics side. And what this call assist does, that there is a system, let's say you want to make a reservation of a car. So you just make a call that, hey, I want to book a car at the Mumbai airport, and you are a registered user, right? So when you make as you are speaking, you are providing the text, the audio is converted to the text, we extract the entities. So you said Mumbai airport car, then it will tell you basically at the Mumbai, basically these are the 20 types of cars are there, which one you would like to have. And if you have already hired a car on the Mumbai airport, it will tell you basically that, hey, these are the 3 kinds of car basically you in the past you hired. And then as you say that I want to drive this to Pune. Now for the Pune, the small car will not one. Then it will suggest you from 20 came to 3 to basically will tell you that this is the best car for you, right? So that is what the intelligence is built in the cognitive analytics. It understands the data that you are providing. It understands your needs, reason from that data, learn basically from your past things, and then it tells you basically that this is the best options for you, right? And that is what we did some work way back in a decade back. Next slide, please. Okay. So now if you look at this in any enterprise, how my data is flowing, right? So data flows Data is generated from the device from several sensors. These sensors could be my different channels. They go through some gateways, and when they go to the gateway on some edge, then some kind of analytics can be done there, and this is called the edge analytics. And I'll give you a very good example, which we did when I was in IBM with one of the a bank. So when you swipe a card, you get SMS immediately. Thank you for using the card on so and so place, on so and so merchant, and so and so amount and the time. So that SMS is going through the gateway, SMS gateway. When it goes over there, we intercept that SMS. We know Mr. Pratik is in Green Park. He's basically spent, he swiped his card of 700 rupees to the Green Park bakery. Now we know, and we know the time. It is basically 1 o'clock. We know basically that this guy visited the Pizza Hut or some restaurant in that area. So analyzing only that SMS and the previous data, we say that here is a 15% discount coupon for you to go and visit Sagar Ratna, or to visit basically Pizza Hut, or to visit any other restaurant. That is what is the edge analytics is, right? That is, you analyze the information which comes on the edge. It's a lightweight, very lightweight. You don't need basically, huge amount of infrastructure to analyze such information. It is a very light few bytes or maybe kilobyte information, right? Analyze that on the edge and push that information, right, to the people, right? And I'll give you one more example in this, and then I'll stop. I have lots of slides, but I will stop that. Then it goes to the network, right? So all the telcos, basically they analyze the network, which is the congested area, because all the calls and signals basically go to the particular tower, right? And this basically that this is the congested area. They may divert those calls to another tower and so on, right? Goes from that data goes to the cloud. And then from the cloud, basically one can do the, analytics on the public or the private cloud there. But typically, basically, any organization, they don't keep all the information on the public cloud, right? Depending on the severity and privacy of the information, they keep it on the enterprise also. Then they analyze that information, right? They might have a different accelerators. And these days, indeed, there are very well-defined, fine-tuned accelerators are given for one type of analytics, right? Because you want to fine-tune or optimize in such a way that it should work on that particular platform. Those who have worked actually on the, on the database optimizations, right? Or basically, developing those kind of algorithms, they know basically that one size does not fit to everyone, right? Therefore, we need to custom made, right, the things. We need to highly optimize a particular algorithm for one kind of use cases. It may not work with that efficiency in another kind of use case, but that is fine as long as basically it is working on the use case that the enterprise is interested in, right? Then it goes on the analytics. Some of the data is pulled in basically on the cognitive. You apply all the cognitive kind of analytics what we just this, and all top of that basically it is completely secured. See, and the privacy, that is the key, that we want to do this analytics in a highly secured way and in a privacy preserving form, right? So let me tell you basically one example, then I'll stop. So one of the things that we are doing in the cloud analytics, that area, the 2 days, at least I have seen in Delhi, that we have a cameras mounted on the pillar, and the camera is basically reading your number plate and seeing basically, the speed. These are the speed camera, right? And they monitor basically for 2 seconds or 3 seconds. If you are continuously basically, in the road of 60, if you're continuously going at the speed of 80, right, they take the image of your number plate and then you get the ticket, which is perfectly fine. They are analyzing that information, take image to text, look at on the database, look at the speed, send that. Now if you want to extend the same idea for the following things. So let me give you some facts, and you can check on the Google. There was a report a couple of or 3 years back in the Times of India that roughly 52% cars in India, not cars, the 52% vehicles, it could be a two-wheeler or four-wheeler, right? They are not insured, but they are still on the road. It's a very serious situation. 52%. They probably insure the car or scooter, when they buy it for 1 year, because for the road registration, they have to pay for the whole life of 15 years. For the insurance, they have to pay only year by year. Or the pollution certificate, they just go for the 3 months or 6 months, depending on where you are living in India, right? So now when we are driving the car, some policemen, traffic policemen basically are there, they stop the car and they ask 3 papers. Sir, show us your registration, show us your insurance, and show us the pollution. And if one of them is not there, they cut the challan or you bribe them. So the question here is how we can use the data analytics technology to solve this problem. And this is the things that basically this idea came 7 years back, and I was just basically finding some students to work on that. So now, since we have the cameras mounted on the pole and when the cars are going, we know the speed and we know the registration car plate number. If we have the insurance database, let's say magically we collect all the insurance from all the companies, the IRDA, Insurance Regulatory Development Authority, basically they make it something, and we query basically the federated insurance data sources that whether this car is registered, has insurance or not. We get immediately information, yes, this has, or when it was the last time taken. Similarly, we have a pollution one, right? And then either we can, even if the speed is same, we can send the letter, right, and to the insurance company of the last bought insurance that, look, this guy is still driving and there is no insurance, right? So it's a win-win situation by the insurance companies, for the country, and for the person, for all the parties, by doing a simple data analytics on the cloud itself, right? Similarly, the pollution one, right? So these simple analytics, which can really change and bring the value to the society in our system, right? So next slide, let me see what is the next slide. Otherwise, I'll stop here. I have, as I said, okay, this is an important slide. So to make the data analytics possible and consumable by the end user, it is very important that we make the data understandable by the system or by the application. As I said, if the data has lot of noise and raw data does not make any sense, because no application can consume it, because when you designed any system or application, you designed to work on a particular pattern or particular schema, and that schema is not appearing on that, how to analyze that information, right? So this is what is how the information flows in building the cognitive systems. And the other part is you might have a great analytics. If that analytics or the outcome is not being consumed or cannot be consumed by the end user, and end user are by who are the end user? The business decision makers. If they cannot understand the outcome, then it's of no use. At the end of the day, the data needs to be consumed. The insights needs to be consumed to take the better decisions, right? So let's understand this whole flow. So we collect the data on the left-hand side. You collect the data from variety of sources, right? And keep that information as long as you need in the next cycle of processing. If the data will never be used for any application and is a complete junk, throw it out, right? Because data is coming at very fast rate, right? Yes, the storage cost is very cheap, but still you can't keep everything unless basically they are, compliance regions or there are other regions to keep the data. So identify the data in which type of data repository it can fit. Is it a SQL, NoSQL, audio files, video files, and so on. So that is the data. You are just collecting the data after some filtering. Then it comes for the understanding. And this is what the cognitive systems, the AI does. That the data which is coming in, understand the semantics of that information, the data. When this data will be used, which data it will be linked to, and how it can contribute to the analytics application. And during this process, on the data understanding process, which is a continuously building and understanding the data, clean that data, right, by applying some kind of rules there, right? And then you link that, okay, this piece of information is linked to that, this is linked to that, and you build a complete, basically a graph kind of things, right? So you provide a feedback, you learn it, you feedback, and then you come back. So this is iterative process. Once you have understood the data, analyze in what context to uncover the hidden information and find a new relationships, right? So we know that this piece of information in the analytics, in the ML is a, let's say there is a feature, right, is defined on that data, right? So let that data basically go and analyze and do the reasoning at the source level. So push the machine learning constructs down in this data ingestion time, so that you can reduce the workload there. So analyze that information, do the reasoning, and do the analytics with respect to the contextual information, the metadata that you have extracted it, right? Then go and learn what is basically appearing, right? Do some recommended interactions, use the context to deliver the point of actions on that. And finally, you adapt that information. Insights, let's say if there is a one insight, business user will understand in one way, the group user will understand, or group leader of that will understand another way, and others will understand in that way. So contextualize and also basically adapt that information insights depending on who are the end user to consume that information, right? So that is what in each of these things I've said in a very simple way, but each of them is very, very big thing. And as I said, 80% of the time, this is a thumb rule. Typically, when we develop any application on the raw data, right from raw data to make the data consumable, 80% of the time basically goes in the data preparation time, right? And this is what is basically the data preparation, which is gathering the data, identifying the source of information, gather that information, understand that information, and do all the curation, cleansing, linking, discovery, and all that information during that. So with that, I will stop here, take few questions, right? Abhinavji, don't share this slide. I will send you, basically, I will let you know what can be shared and what cannot be. Okay, so don't share slides.
Sure.
Okay, right, wonderful. And let me take few questions here, and then I will stop 10 minutes from now because I have a hard stop. Thank you. So how we are taking the questions?
Yes, sir.
Yeah, participant, just raise your hand so that you can ask the questions. Yeah. So,
Yeah, Dr. Ghosh, please ask your question. Dr. D. Ghosh. Dr. Ayushi Soni.
just unmute them so that they can ask.
Yeah, sir, we have unmuted.
Okay.
Yeah, Ayush Soni, you can unmute. We have allowed you to ask the questions.
Participants, just unmute yourself and then ask the question. Yeah.
I think they are having difficulty in unmuting themselves.
Yeah. I think so. Just give them right. So, just check. Just check whether they so that they can unmute themselves.
Yeah, participants, now you can unmute and ask questions.
Yes, sir.
Hello.
Hello, sir. Dr. Ghosh this side.
Yeah.
May I ask question?
Yeah.
Ghosh, boliye.
Sir, it's a very nice.
Can you introduce yourself if you don't mind? Just basic from which institute you are there.
Yes, sir. Myself, Dr. D. Ghosh, Associate Professor of Business Administration, Assam University, Silchar.
From where? Sorry.
From Assam University, Silchar.
Okay, lovely. Yes.
Yes, sir. Sir, it's a nice presentation. Now, one query that come up to my mind is that in this data analytics and business analytics, whether the packages like R and Python are necessary to be introduced in order to carry out the business analytics, sir?
Answer is yes, because rather than you build your own library of functions from scratch, since they are available basically in R or Python or any other ones, why don't you basically use them? Right? Thank you. Yeah, next one.
Next question, please.
Hello.
Yes, go ahead, please. Yes, go ahead.
Yeah, I am Saurabh. Yes, sir. Good morning, sir. I am Saurabh.
Saurabh ji, boliye.
Sir, my question is that I am very new to this field. That how can I start? From where I can start these things, this type of things, so that I can explore so many things that I can in future I can do more works in this.
Okay, so I think first you should get familiarize yourself on the analytics capabilities in the Excel sheet, right? That what kind of analytics in the Excel these days, Microsoft Excel provides you a lot of analytics, right?
Yes.
Then there are a lot of open source data, plenty of data. Basically, if you go to the data.gov.in or any government organization, right, data, you can pull out agriculture, census, this, that, all the data, and do little bit of descriptive analytics first. Run the what if kind of scenarios there, and write these small programs in Python or R or any your favorite language, right? Pull this data into the relational databases, you have a MySQL, for example. It is an open source one. So get the data in the MySQL and start analyzing it. Okay.
Next question, please.
Hello.
Yeah, go ahead, please.
Hello, sir. This is Usman from Untitled University, Lucknow.
Hello, sir.
Hello, sir.
Go one by one.
Okay, sir. So this is Usman from Untitled University.
Yes,
Sir,
Usman bhai bolo.
yes, this my question is about how we can perform data cleaning steps on multimodal data analytics.
Sorry, how we can perform what?
Data cleaning steps on multimodal data analytics when we are taking the data set like text or audio or video or visual data.
Okay.
How we
So,
can perform that?
right. Okay, I got it. See, if you are doing the data training on the multimodal data analytics, you need to look at basically what is your end application.
Yes, sir.
Right? With that end application, and I'm assuming that your multimodal data is already cleansed.
Yep.
Okay,
Yep, yep.
already cleansed. So in the, let's say basically in the end application is about your face recognition. Let's say assume. Okay, and you want to identify that what are the emotions, whether it's a guy is happy or unhappy or sad or this or that, right? So now, given all the data that you have to basically analyze manually initial, right? You have to take the information manually and train the data, and then you take basically any existing algorithms, right? On the different open source APIs are available. Just you give your data, run on that, and that it will give you basically other data to be analyzed with respect to the emotions.
Okay.
Sir?
So can we associate this type of information with human behavior?
Yeah, well, why not? You can, and we are doing basically we are using the Sri Guru Granth Sahibs or Gita and Mahabharata and Quran and other religious scriptures to correlate the emotions with the people's situation. In this, as I said in the example, like people are depressed and how the depression is being dealt in the Mahabharata, what Lord Krishna gave the message, right? Or in the Sri Guru Granth Sahib's one, right? Or in other scriptures language. So that is what we are working on.
Thank you,
Sir? Hello.
Yes.
Sir, I'm Shivashish, and I'm the first year student from Technocrat Institute of Technology. Sir, my question is that you told about the data which can be fetched while using the camera, which is just mounted on the pole, the vehicle data. Sir, in the cognitive process of data, it is necessary that all data is converted into a text, because sir, there is also a system like a barcode and QR code can just rapidly convert these types of data that can understand by a machine in easy way.
Right. So what is your question?
So my sir, actually my question is that it is important to in cognitive data that the information gathered by the person is converted into a text. It can just yes sir.
No, it can be any other. You have a pattern recognition, you have a computer vision. There, the information, you look at the boundary and that you just basically do the morphing the videos and look at that. So it doesn't need to be converted. The example that we gave, because in India the number plates there are no standards. In your number plate you can have DL blank 1C blank 4597, whereas in my things I can have DL 5C. There is no one continuous one word, right? So since there are no standards, we have to convert that into a text, right? But in real life, in any multimodal data analytics, you don't need to, right? You have a video data analytics. You want to look at basically the video stream where you see the fire or any knife or this. You want to detect those frames. Then you don't convert that, right?
Yes. Yes. Sir.
Okay.
Sir,
next. Yes.
Sir, my name is Abhishek, and I am a first year student in DTU. Sir, my question is, which language does I prefer to analyze the data, and what are the sir, and how can I understand data analyst for the beginner?
So as the first, basically the Dr. Ghosh said, you start with any your favorite language, right? Any favorite, let's say Python, these are very popular, or R. You just basically get that, use the Python R library and on your data. But you have to look at basically whether those libraries can run on your data set or not. So you have to prepare the data, right, that can be used by any language that you prefer, and depends on what kind of analysis that you are doing. Okay, next question, please.
Hello.
Yes, sir.
Yep.
Sir,
Hello.
I am working from
Hello,
Can
sir.
you ask one by one?
Hello, sir. This
Hello.
is Pranshi, and I'm working professional. I have experience of around 10 years in QA. I'm working as a QA manager in one of the banks. So my question to you was, I wanted to change my domain and I want to make move to business analytics. So now
So
Your voice is not clear.
can you hear me now?
yes, go ahead.
Hi, I'm Chitranshi Agrawal. I am working with experience of around 10 years.
Mhm. Go ahead, चित्रांशी जी. आई थिंक आपका बेटा या बिटिया आपको वो कर रहे हैं. चलिए, चित्रांशी जी आपको बाद में लेंगे.
Mukesh, if I can utilize the time till the time Chitranshi come back.
Yeah, go ahead.
Hi, this is Aditya, and I'm also an industry professional. Okay. My question is around one of your slides where you presented a point in time in your graph that we are moving towards blockchain and analytics combination. But is it still a reality now? Because we understand blockchain have a lot of encrypted data.
Okay.
And
so I got you, Aditya.
That can hold a lot of dirty data.
Right. So Aditya, if you look at basically, I put a question mark there. Blockchain is, to me, is more hype than reality. Okay. So, but if you need a foolproof trusted, where multiple parties are working to execute a single task, and when there is a lack of trust between these parties, then probably the blockchain is the right answer. Right? But I agree with you, the blockchain is more hype than the reality, and there are not too many applications which can not be done using the distributed databases or the centralized databases. But when multiple parties, they are collaborating to execute a single task, and there is a lack of trust, then probably blockchain could be one of the alternative there. Okay. Yeah. Next question, please. Yes.
My question to you is, how do we measure the actual state of an analyst? What are the metrics?
Lot of disturbance from your side.
Chitranshi ji, if it is you, I can't hear you. If you can come closer to the microphone, right? And I will take this last question. As I said, I have a hard stop in 3 minutes for my next meeting. Yes, go ahead quickly.
Hello, sir.
Hello.
Can you hear me?
Hello.
Yes, I can hear you. Yes.
Sir, how
Hello,
do we
Mukesh, sir.
move our career to business analytics from a QA domain?
How can you
move our career to business analytics from QA
quality?
Oh yeah, okay. So see, you should really know in and out of the data analytics. So as I said, look at the Python, right? What kind of libraries are available, and you should have a hands-on experience is playing with some of the data. Right? You go, as I said, on the internet, you have plenty of data, all kinds of data. Right? You go to the Kindle, basically look at all kinds of data you have there. Right? And then just play with that. Once you feel that one, you apply for the position from QA to data analytics. And I'm pretty sure basically you will, but use some case studies. Like I use some of the case studies. I mean, in this presentation, I just reached to 1/4 of the presentation, but I have a lot of case studies on the rest. So understand what are the requirements of data analytics in the telco or in the finance or in the retail industry or in the any other industry which is favorite to you, wherever you are working. Okay, so with this, I have to stop, unfortunately. Thank you so much, Sanjay ji, and your team for inviting me here. And thanks all the participants. I really enjoyed interacting with you, and I'm extremely sorry basically for the technical glitch in the beginning. Right, wish I could have spent more time, but nonetheless, I wish you all the best for your rest of the FDP program. Thank you.
Thank you, sir, for giving us your valuable time.